Swayam Prabha. Digital India. Educated India.
So last class I have discussed about the size of earthquake, and then previous that I have solved one example problem to show you how we can locate the epicenter of an earthquake, and there we use the latitude and longitude for 3 different stations, and then we have to convert that how for 1 degree change of latitude or longitude that distance will change in terms of kilometer. Okay, and then remember that in there I have changed it with respect to one particular station, that is the reference station, and there I selected that station 1 is the reference station. So ideally that latitude longitude change and the equivalent distance change in terms of kilometer, that should be in terms of with respect to reference station. But in that problem, as all the stations were very close to each other, so we consider a common distance, but actually it should be with respect to the station 1. Similarly, here also I solved a few problems related to size of the earthquake, and there and I have shown one particular figure where we can determine the moment magnitude if I know the other magnitude or vice versa. So there I want to say one thing, that if you want to determine say seismic moment, so to that you need the moment magnitude. From there, if you know the moment magnitude, from there you can determine the m0 seismic moment, or vice versa. If you know the moment magnitude, then you can determine the if you know the seismic moment, you can determine the moment magnitude. Suppose if I want to determine the moment magnitude or the moment seismic moment, to determine the seismic moment we need the moment magnitude. Now if we have the shear wave magnitude, then how we can determine the moment magnitude, or how we can determine the seismic moment. So then you can use that chart, convert the shear wave magnitude to moment magnitude, then that moment magnitude you can use to determine the seismic moment. So that's my idea is that you can convert the different magnitude by using that chart, but remember that you have to careful that which other magnitude you can consider. The moment magnitude for a strong earthquake also you can consider, but for other magnitude there is a saturation problem, so you cannot consider those values. So that I have given the limit, so that those values should be within that limit. Then you can convert it to moment magnitude, and then you can determine the seismic moment. So that was the module 1. So where I have discussed about the causes of earthquake, then the location, how to locate the epicenter of an earthquake, and then the size of earthquake, what are the different type of scale, that is intensity based scale, magnitude based scale. Now today I will start my next module, that is the strong ground motion. Okay, so first we define that what is strong ground motion. Then I will discuss about the other parameters and then how to measure those parameters. So strong ground motion is the motion with sufficient strength that affects people. That means we during that ground motion, the motion which sufficiently strength has the sufficient strength and that can affect people, that portion of motion is called strong ground motion. And we can define how what is the strong ground motion duration. So those things we will discuss. Now to study the effects of earthquake at a particular location, quantitative description of strong ground motion is required. So that the effect of that strong ground motion or the earthquake effect on a particular location, to study that you need to quantitatively describe the strong ground motion. Now, as a particular location, ground motion completely described by three components of translation and three components of rotation. So, the translation means you know that one is your horizontal, two horizontal motion, okay, and one is vertical motion. So, that means two horizontal components, one vertical component. So, that three translation components and three rotational components also. Okay. So, generally these are the 6 components, but in practice these three rotational components are generally neglected, okay, because they have less effect compared to other three translation components. So, that is why these rotational components are neglected generally. The three orthogonal components of translation are generally measured, because as these three components are perpendicular to each other, because if you say there is x, y, z. So, x is one horizontal component, y is another horizontal component and z is the vertical component. So, these three orthogonal components of translations are generally measured, and then I will discuss how we will measure that. Now, for engineering purpose, three significant ground motion parameters are amplitude, frequency content and duration of the motion. So, as I mentioned how I will define the duration of motion, so that also will be defined. So, there is three components: amplitude, frequency content and duration of the motion. These are the three significant ground motion parameters. In addition to these three parameters, there are other few parameters are also there. So, those will also be discussed. Now, these parameters are used to characterize a particular ground motion. Okay. So, before I start how to measure these parameters, okay, so let us start or let us discuss our the basic thing, what is amplitude, what is frequency, okay, and what is the time period. So, let us start with that part. Let me discuss about that part and then I will discuss how we can measure those parameters. Okay, so now if I take one simple harmonic motion, okay, so that is simple harmonic motion. Now, what is a simple harmonic motion? The simple harmonic motion that can be characterized by sinusoidal motion at constant frequency. Okay. So, first this simple harmonic motion I can represent in two ways. One is the trigonometric notation, another is that notation is in complex notation. Okay. So, first I will discuss about the trigonometric notation, then I will discuss about the complex notation. So, first that we are using, that is the trigonometric notation. Okay, as it is a simple harmonic motion, but later on we will show that actual earthquake loading is not the simple harmonic motion, it is not that simple. So, but how we can convert that and then how we can solve and how we can get the response, those will be discussed. So, first we will start the simple one, that is simple harmonic motion, and that I have already mentioned, that can be characterized by sinusoidal motion with a constant frequency. So, now if I say displacement, u is the displacement of a motion is a into sine omega t, omega t plus phi. Phi is the phase angle. Now, what is that? Where your u t is the displacement, okay, and a is the displacement amplitude. So, this is the your amplitude, and omega is the circular frequency or angular speed. Okay, and phi is the phase angle. Now, what is phase angle? Now, phase angle is the amount of time by which the peaks or 0 points are shifted from those of a pure function. So, I will show you by graph. So, now here if I draw this graph for this particular case, and before that if I put that your ut is equal to 0, when ut is equal to 0, what does it mean? That your omega t plus phi should be also 0, because your sine 0 is equal to 0, but a cannot be 0. So, now I can write that phi is equal to minus omega t, or t is equal to minus phi by omega. Okay. Now, again this omega t plus phi, that we can write also, there be another equation that way we can write that ut is equal to a sine omega t minus phi also. Phi can be positive, phi can be negative also. In that case, if ut is equal to 0, then your omega t minus phi will be equal to 0, or the phi will be equal to omega t, and t will be equal to phi by omega. Okay. So, what is the meaning of these two cases? So, first case, if I draw, this is your t and this is your displacement. Okay. Now, here when your u is 0, when your u is 0, that means u is 0, that time there is a your t is minus phi by omega. Okay. And now if your, so in that case I can write that this is my expressions or the plot Okay, so that means here this is your A is the amplitude, that means here this is 2A, this is also A, this is also A, so this is 2A, okay, and here your from here to here this is your T period, and that is equal to 2 pi by omega. I will discuss how it is coming. And then another one, this is, this value is what? This value is where your ut is equal to 0. So, when ut is equal to 0, first case this is omega t plus phi. So, when ut is equal to 0, the t is equal to minus phi by omega. So, this is your t, this axis is also t. So, this value will be minus, and minus no need to write the minus because it is only in the already in the negative side. So, it will be simple phi by omega. So this is first case. Now second case, when your phi is positive, negative, then your this is phi by omega. Okay. So in that case, it will start from here, then it will reach here, then it will come down, like this. So here also this is your amplitude A, and this one is equal to time period, that is 2 pi by omega. And now what would be this value? This value is this t value, you can see t is equal to phi by omega. So this will be phi divided by omega, and obviously this total one will be equal to 2a. So this is t and this one is ut. Okay, so that means here we have two phi value. So one is the positive phi, which indicates that motion leads the sine function and if it is a negative phi, which indicates that motion lacks the sine function. Okay. Now we have written that this one, if I write this is a circular angular speed or circular frequency. Now if I represent that in this form, that this is my t axis and this is ut axis displacement, and it is moving in a circular motion, and that is omega. So this is omega is the circular motion, and now if at any angle omega t, so this is the omega t angle. Okay, this is the omega t angle, and if this value is a, then I can write this is what? This is omega t, so this will be a sine omega t. Okay, so now here you can see, because if we take u t is equal to a sine omega t. Now we have taken that this further simplified form of that ut, that is a sine omega t, and it is moving with a circular angular speed of omega, any angle omega t, this is a value, this will be a sine omega t. Now from here, where will be the maximum value of u? So you can see the maximum value will be at omega t is equal to pi by 2. So at pi by 2 it will be maximum. Okay, because at pi by 2 sine pi by 2, that is 1. So that will be maximum. So maximum value will be, if it is 1, will be that a amplitude. Now then if you go to pi, omega t is equal to pi, it will be 0. That omega will be, this is omega t, that means this u will be 0. Then it will be again maximum at omega t is equal to 3 pi by 2. Then again at 2 pi it will be 0, and then it will complete that. Again it will be in the same way, it will go. And so here this it will be basically positive, negative, this will be positive. Okay. Now here I have discussed the T. T is the period of vibration. So if the T is the period of vibration, or I can write the time required for one cycle of motion. Okay. So here you can see this is one cycle of motion. If you start from here, then go up. So that is one cycle. Then another cycle. You can start from here also. You start from here and it will end. So that is a total one cycle. So that means the time required to complete that one cycle is your period of vibration. How I will express that? So now you can write that one cycle rotation is equal to 2 pi. And angular velocity or speed is omega. So time required for one complete cycle will be simple 2 pi by omega. So that is equal to your 2 pi by omega. So clear how this T is equal to 2 pi by omega is coming? Okay. Now when you know the time period or period of vibration, there is another time that is important is the frequency. Frequency is what? Frequency is basically, it is called F. So that is basically the number of cycle occur in a particular time period. So number of cycle occur in a particular time period. Okay. So in that case, I can say the frequency is 1 by T, and that will be equal to omega by 2 pi. Because if T is 2 pi by omega, this will be omega by 2 pi. So that means the time period is time required for one cycle of motion, that is called period of vibration, and then number of cycle occur in a particular period of time, then that is called the frequency. Clear? So these I have given the basic idea of this by considering one a simple harmonic motion. Now this simple harmonic motion can be represented in another form, that is equal to A cos omega t plus B sin omega t. Okay, it can be represented in this way also, and then that you can write as A sin omega t plus phi. So I will discuss what would be the value of phi in this case, because we have taken first one is a very simple, that is A sin omega t, and then we have discussed that. Now we have taken the A cos omega t plus B sin omega t. Now and then I will convert it to A sin omega t plus phi, and now I will determine what would be A value, what would be the phi value. Okay, so now if I draw that, so now again if I draw, so this is your u or ut. Sometimes I may write u or sometimes I may write ut also. So that means here this is your b value, and now you know that any cos theta is equal to sin theta plus 90 degree. So if this is your b and this one is omega t, so this will be definitely b sin omega t, and the cos function is sin plus 90 degree. So now the next one, this a, this will be a, and that will be definitely by an angle of 90 degree. Clear? So this is a. So now this value, if this is a, now this and this is 90 degree, and now next omega t, this is your omega t, and then this is 90 degree. So this definitely this value is also omega t. Okay, so this is omega t, then 90 degree, so this total is 90, so this value is omega t. Now if this is omega t, then this value will be b cos omega t, because this is omega t, so this will be, this one will be definitely b sin omega t, and if it is omega, so then this will be sin, so this will be cos, b cos omega t. Okay, so now if I combine them, these figures may not be as per scale, so remember that. So if I combine them, then this will be b, okay, and this one is omega t, and this is a 90 degree, so this is a, this one is omega t. So now if I take the resultant, so that is equal to a. So that a, how can I write that? This is resultant, so this will be root over simple a square plus b square, and this will be my phi angle. Okay, this will be phi angle, which is making with that b. So that means here phi will be equal to simple tan inverse a by b. So this is a, this is b, so this is phi angle, so this will be simple tan inverse a by b. Clear? So that means I can convert this thing to this equation, where if we have this type of equation, a cos omega t plus b sin omega t, then we can convert it to a sin omega t plus phi. So a will be root over a square plus b square, and phi will be tan inverse a by b. So this is my trigonometrical notation. Now if I consider a complex notation, why complex notation is required? Because sometimes use of trigonometric notation makes very long equation, and if I put them or express them in complex notation form, then it will be easier to solve. Okay, so again I am taking that simple harmonic motion, that in the complex notation also, that is ut is equal to a cos omega t plus b sin omega t. Okay, now using Euler's law, what it says, that e to the power I alpha, that is equal to cos alpha plus sin I sin alpha, or e to the power minus I alpha, that is equal to cos alpha minus I sin alpha, where I is equal to root over minus 1, which is a imaginary number. Okay, now if this is the thing, then I can express that cos alpha can be expressed equal to I e to the power I alpha plus e to the power minus I alpha divided by 2, because if I add them, then I will add these two equations, then I will get the cos alpha expression, and similarly I will get the sin alpha expression also, that is minus I e to the power I alpha minus e to the power minus I alpha divided by 2. Now, if I put this cos alpha and sin alpha value in this equation, then finally ut I can express in the form of A, then it will be alpha is basically here equal to omega t. So, it will be E I omega t plus e to the power minus I omega t divided by 2, then minus I b e to the power I omega t minus e to the power minus I omega t, that divided by u. Okay, and further if I simplify it, then I will get A minus IB divided by 2, then e to the power I omega t, then plus A plus IB divided by 2, then e to the power minus I omega t. Okay, so this way I can express this simple harmonic motion in complex notation also. Now, one more thing that I want to show you, that I have the ut expression that is equal to A sin omega t. Now, from there, this is displacement, how I will get the velocity? Then velocity will be u dot t, and that is simple u dut divided by dt. So, if I differentiate that, this will be A omega cos omega t, if I differentiate that. So, this cos omega t I can write that A, or this is W A, this will be sin omega t plus pi by 2, then I can convert it to cos omega t. Now, if I further differentiate it, then I will get the acceleration u double dot t. So, that is basically d2 ut by dt square. So, this will be equal to minus omega square A sin omega t. Now, that I can express omega square A sin omega t plus pi. Okay. So, now if I represent them, now this is my first one, that is, say this is A and this one is omega t. So, this is A. Now, second circle, that will represent the velocity, and then velocity will be by pi by 2 by 90 degree. So, this will be in the second circle, this will be my A omega, this will be A omega or omega A, but that will be by 90 degree. And third one, if I draw the acceleration, then this will be pi omega t plus pi. So, this will be the straight line, and this value will be omega square A, and this is moving with an angular velocity of omega. So, you see this angle omega, then this is A. So, this one is basically, this is the velocity, this one is the displacement, and this one is the acceleration. So, these are the acceleration amplitude, this is velocity amplitude, this is displacement amplitude. Okay. So, that means why that velocity will be 90 degree pi by 2 from the displacement, and from the displacement your acceleration will be plus pi. So, that is plus pi. So, this is the representation of velocity, displacement and the acceleration, and I have already expressed the asymptotic harmonic motion in terms of trigonometric notation and in terms of complex notation, and I have discussed what is frequency, what is time of vibration, or what is your amplitude. So, next class I will discuss that how, because I have discussed that the three major parameters. Those are, what are those three major parameters? That is amplitude, frequency content and duration. So, then next class I will discuss how I will measure those parameters. Okay? Thank you.